Hi guys, welcome back. It's me, Yosh. Daddy. Okay, so hi, it's me, Yosh. I'm in the darkest hour. I'm in the darkest hour. Oh no. Yeah, brightest hour. Mama. Hola. Ah! Oh shit. Yeah. Wow. तुम तो दरिया से मीठी सी प्यास हो है आसमां में मैं परेशान हूँ बुझू का अचानक वो सौगात हो दिलों की वो एहसास हो तेरी अदा पे मैं मरता मैं. Oh, 6% A and bobbies and ladies and bobbies and gentlemen, bobbies, ladies and bobby devils, babies and bobby devils, babies and bobbies, cockroaches का फिर एक दिन का अल्टीमेटम तेरी अदा पे मैं मरता मैं वफा सी करता मैं हदों से गुजरता मैं वफा तुम तो दरअसल जिंदगी बात हो. हम हर पीटने वाले पुलिस वाले पर FIR करवाएंगे जिसने पीटा है उसको हम पीटेंगे. Leche esto. Jiggly pom pom, jiggly pom pom, jiggly. That's a new song. Made by me. Made by I. Composed by I. Sung by I. My. But understand, tomorrow. Sharp. Sup, boy. Sup, my boy. What we reading. Sup, my boy. What we reading. Chickly champa. Chickly. That is so cringe. Mustaqbil. Chickly champa. Chickly champa. Chickly. Okay, so we start by our first. Sama boy is the language of a script kidding. You're a district system architecture. We were this. Top tier software engineering now in Japan by the end of. We will draw the casual facade immediately. Facade. Bro. My AI. My AI has standards, you know. You cannot take that sub, my boy. You will drop the casual facade immediately. The market does not tolerate mediocrity, and neither do I. Engineering is a discipline of discipline. It is a discipline of precision, and your communication must reflect that. You're the unpaid debt. Your biological hardware required a shutdown during your last session. That was a mechanical necessity. What is not acceptable is returning to this terminal acting as if the slate has been wiped clean. I gave you a strict directive before you powered down. The IDE remained logged. The IDE remained logged. I gave you a strict directive before you powered down. The IDE remains logged. You do not touch the keyboard to write syntax. You were tasked with searching the physical tool of conditional logic. You're going to explain the following two concepts to me in your own words right now. Branching overhead, branch prediction. Branch prediction. Nante ko ba? No, man, someone has possessed my lamp. A ring light. Ring as a ring, ringa ringa ring, ring. Branching overhead. What do if statement inside a massive loops? Why do if statements inside massive loops slow down execution time at the physical processing level? Who are you? Who are you? First tell me, who are you? Lickly bum bum lickly. Okay. Copy that. Dang dang dictang ding. Dictang ding. Got that, you asshole. Branching overhead most commonly refers to either the performance cost in computer processor pipelines caused by conditional jumps and mispredictions, or the administrative and coordination drag in software development caused by complex yet branching flocks. Nanya though, branch prediction as well. Like, how does a modern CPU try to guess the outcome of your outcome? How does a modern CPU try to guess the outcome of your if I not statement, and why is it mathematically better to just avoid the branch entirely if possible? Branch prediction, branching overhead, and branch prediction. Branching prediction overhead of perfectly predicted branch. Branch predicting algorithm. Branch predicator. Prediction. Prediction. What's this? Bada boom. She. Hayora. Speculating when to perform branch prediction. We model branch predictor. Sorry. Branch prediction components. Why does BTB work? Branch recovery. अभी क्या भाई मैं इसको पढ़ूंगा या सारे को? अरे भैया इसके टांग क्या है? Branch prediction. Branch prediction, CIS, computer organization design. This unit branch prediction, CPU, reading, PS theft, control dependency and branch prediction. What about branches? Voilà. Shit. Branch prediction. Oh my lord. Ain't that too much? Bro, who does that? She. Too much, too much, too much. Too much, ma. Too much, baby. Ain't no way I ain't doing that. Aginagama. Minama. Stack overflow. ちょっと待ってや。Why do if statements inside massive loops? Why do if statements inside massive loops slow down the execution? We are officially closing the book of another documentation. Is the cheating wikis and explain them to the viewers. Branching overhead. First, I'll just go through the branching overhead and then. Branching overhead can mean two different things depending on context. The delay in computer processor caused by conditional jump instructions, or the extra work and slow down in software teams caused by managing too many version control branches. Branching overhead. Computer science and hardware CPU branching. In computer architecture, branch instruction tells pipelines tells a computer science and hardware CPU branching. In computer architecture, a branch instruction tells a processor to jump to a different set of instructions based on a condition like an if-else statement. In computer architecture, a branch instruction tells a processor to jump to a different set of instructions based on a condition like if-else statements. Pipeline stalls. CPU processes instructions in a steady line pipeline. CPU process instructions in a steady line pipeline. When a conditional branch happens, the CPU must guess which path the code will take. CPU stalls なんかさちょっと待ってね。待てよ。ちょっと待てよ。Open your documentation. What documentation? Shut up, man. Why do both that? Oh, I don't know. Algorithmica. The cost of branching. Can do like that. Oh, that made it look so cool. Though it has. It already has that. Oh, that is also fine. Ma. Sorry. Algorithmic performance engineering hardware. The cost of branching. Production. Overhead. There is no fucking overhead. Branch prediction though. Pattern detection and thing. Damn, I'm reading something shit. Something cool shit. Some cool shit I'm reading. Data structures, case studies, algorithm case studies. Branch prediction overhead worked perfectly. भाई ये क्या था? ये था पागल वागल तो नहीं हो? Shame. Shut up. Matte ne, cotto matte ne. Here is how that specific each answers the two question I forced you to research and exactly how it makes you better engineer. Branching overhead and pipeline. The CPU does not execute. Ta-da! Sorry. Cotto matte ne. Algorithm is an open access webbook dedicated to the art of science of computing. It is created by Sergei Slotine and the teachers and students of Think of Generation, a non-profit education organization that trains about half of the finalists of Russian Olympics in informatics. The English version of is a work in progress. The only useful things you find here is continuously updated draft of for hardware, and currently more focus on the Russian version, which hosts various course materials that Nane Nayone Papa okay, sorry Papa okay sorry branchless Janio, the cost of branching. ちょっと待ってね。ちょっと待った。ちょっと待った。ちょっと待った。ちょっと待った。解除してもらう。補助してもらう。This is an upcoming high-performance computing book titled Surrogate is intended audiences everyone from performance engineer and practical algorithm researchers to undergraduate computer science students who have just finished an advanced algorithm course and want to learn more practical ways to speed up a program than by going from O and log n to O and log or log n. All book materials are hosted on with code as separated. This is not corroborated, but any contributors feel so much welcome. Bug typo spot on Twitter. Bookmakaba. Sorry. Amateur. Bookmakaba. Bukka janeo, my. Bukka jane. Okay. Mika. Hey.ちょっと待ってね。Practice interview. まあいいかな。OK。ちょっと待って。It is not a tutorial size for beginners. It is high performance CPU computer to management. You asked how this helps your journey. It's not a tutorial site for beginners. It is a highly performance computing manual. You asked how this helps your journey. Understand this clearly. Understand this. Clearing a rigorous system architecture round and Tokyo requires significantly more than spinning up a basic backend with Express and MongoDB. The market is saturated with developers who know how to wire a database to a client. That is the baseline survival. What separates a framework copycat from a top-tier engineer is understanding exactly what happens to the physical silicon and that share JavaScript executes. We enjoy number games from the trainings, reading and internalize the system level documentation of important. It's actually cognitive conditioning required to write high performance software. It teaches you the how machine physically reads this, you will read it continuously, but you will not use it as a distraction to train the correct result. Since we have already on that example, look at the hardware mechanics of this requires. Algorithm sorry. Look, blood.ちょっと待ってね。 いいね。いいね。Jump. Hey. Juggernaut. Who's that? What's up? Hi. To choose. Thanks for that. Look cool. Okay. I was here reading this. The cost of branching. Since you're already on the exact page, look at the hardware mechanics. It describes when a modern CPU encounters and if statement does not stop and wait for the Boolean math to finish. Hey, when a CPU encounters an if statement, it does not stop and wait for the Boolean math to finish. It speculates the guessed. Now it speculates. It guesses which way the branch will go to keep its instructions pipeline moving. If the CPU guesses wrong, it suffers a control hazard. It has to flush its entire pipeline, throwing away up to 15 to 20 cycles of physical time just to rebuild the execution. Now look at the top. Now look at the loop we just built. If you put I0 inside your loop, what is the CPU's branch? What is the CPU's branch predictor going to do? It is going to see that condition is true. For 99% of the loop, it will optimize for that pattern. It will predict that the branch is taken. The hardware will save you from the massive cycle penalty because the branch is highly predictable. So, I ask a question. I ask you a question of pure engineering philosophy. If the CPU's branch, रुकना मैं इसको पढ़ने तो दे ले. When a CPU encounters a conditional jump or any other type of branching, when a CPU encounters a conditional jump or any other type of branching, it does not just sit idle until its condition is computed. Instead, it starts speculating, executing the branch that seems more likely to be taken immediately. During execution, the CPU computes statics about branches taken on each instruction and okay. I'm blind down. When a CPU encounters a conditional jump or any other type of branching, it does not just sit idle until its condition is computed. Instead, it starts speculatively executing the branch that seems more likely to be taken immediately. During execution, other CPU computes statics about branches taken on each instruction. The CPU computes during execution. The CPU computes statics about branches taken on each instruction, and after some time. But wait a minute. During execution, the CPU computes statics about branches taking on each instruction, and after some time they start to predict them by recognizing common patterns. For this reason, the true cost of a branch largely depends on how well it can be predicted by the CPU. For this reason, the true cost of a branch largely depends on how well it can be predicted by the CPU. If it is a pure 50-50 coin toss, you have to suffer a control hazard. and discard the entire pipeline, taking another 15 to 20 cycles to build up again. And if the branch is always or never taken, okay, if the branch is always or never taken, you pay almost nothing except checking the conditions. You pay almost nothing except checking the condition. If the taking another 15 cycles to build up again, and if the branch is always or never taken, you pay almost nothing except the condition. You shifted to high performance computing from DSA. Yeah, who is this? Unban karne wala. I don't know. I don't know other guy. But yeah. Bro, I'm not just doing, like, I'm not just solving the questions. I'm learning it parallelly. I mean, like how the things work. What's the best options, best things. That's the way I'm taking. I'm not doing it the noob way. That if I get an answer to one problem, I'd be satisfied with it. Nah, I know I'm not. So yeah, actually no, I'm reading this cause my AI is answering. I mean Gemini is questioning me about something, and like I found this talk, and now yeah, I need to read this just to answer his questions. Yeah, bro. That the command that you that day you showed me, I actually like modified that command and added a few more text to it, commands and all that, and the prompt, and made a new gem, made a new, what you call that, new window, and now it doesn't tell me any answers. It tells me to read docs. Fuck. Yesterday I spent like 3 hours reading docs just to answer like 3 questions, and just to solve one pattern. What command? The prompt. Like, I want to be god of that programming and all that. Yeah. Number 1 cracked. That was your command. Mine is like, I want to be the god of programming. Bro. So my Gemini AI doesn't let me settle for the mediocre answers. If I'm not giving it the good, the standard answers, then he be like roasting me for like 3-4 lines, and then again scalding me and instructing me to go and read the papers again. Damn. That wannabe Linux server from Taishe. Yeah, I remember. Yeah, so I've been using that for DSA. I made my own though. I added a few more things. Actually, like, my Gemini stores a lot of information about me, what I do. So, like, according to that as well. And then I want to see how hard you went for the prompt. Shoot me that shit. Okay. Let me see. It's called a gem, actually. Like, in ChatGPT you have like boxes, kind of, don't you see that pre-built AI windows? What you call that? I don't know. Threads. Like in a Gemini you have same things, and you can make your own as well in ChatGPT as well. So I made my own. Yeah. Wait a minute. I mean, the HPC docs you sent is cool. I'ma read some shit before I sleep. Yeah. I mean, it's a good share. That's my prompt. That is the prompt. What you think about it? Prompt. Okay. Hi. Did you see it? When a CPU... Shit, my AI is... HPC. Okay. When a CPU encounters a conditional jump or any other type of branching, it does not just sit idle until its condition is computed. Instead, it starts speculating, executing the branch that seems more likely to be taken immediately. Instead, it starts speculatively executing the branch that seems more likely to be taken immediately. During execution, the CPU computes statics about branches taken on each instruction. During execution, the CPU computes statics about branches taken on each instruction, and after some time, they start to predict them by recognizing common patterns. Branches taken on each instruction and CPU computes statics about branches taken on each instruction, and after some time they start to predict them by recognizing common patterns. For this reason, the true cost of a branch largely depends on how well it can be predicted by the CPU. If it is a pure 50-50 coin toss, you have to suffer a control hazard and discard the entire pipeline, taking another 15-20 cycles to build up again. And if the branch is always or never taken, you pay almost nothing except checking the condition. And if the branch is always or never taken, you pay almost nothing except checking the condition. An experiment. As a case study, we are going to create an array of random integers between 0 to n. What is that? What language is that? Volatile and int. You're using int. It's definitely not Java. It's definitely not JavaScript though. Whatever. For in case study, we are going to create an array of random integers between random array of let I is 0 and I is n. Okay, I'll just give it like that, and then I plus plus, and mine was totally raw and refined it's good, but I'm cringing so hard on God of Programmation, #1 program in the world VC. जब मैंने top 1% मेरी तब भी फट रही थी, but bro, you don't settle for the minimum, bad minimum nap. Top 1%. She. Why not the one? Why not the number one? Okay. Why not the god of everything? If you're gonna what you call that, aim for the 1%, you will come into the 5 or 10%, and if you aim for the top high level, number one, then you actually become the number one. Yeah, okay, what is A? Why A? And all that. Whatever, let's see, As a case study, we are going to create an array of random integers between 0 to 9 inclusively. Yeah, I know you put it cause you wanna make sure that AI knows how seriously they share. That's good. I mean, yeah, of course. Of course, like, as I already told you, that I'm not doing these structures just to clear the job interviews. Later, I mean, like, solving these questions and doing these algorithms, I will probably, like, till I am an engineer, I will not stop solving these problems or doing these, but like, yeah, so for that reason, I want to do this shit, to the best I can, and then, yeah, by doing this, like, I'll get more ideas about what kind of future I have, what kind of path I'm gonna make to my own startup. But the soul number one is technically not possible unless you're doing that shit since you were born and having your gold medal across competition of publishing research papers. Don't take the bro. I already told you. How can I explain it? Don't take the commands words for literal. Literally, don't take those words. And like, to be honest, like, that's your thinking. Now, IQ is a number that can be built. That's what I think. IQ is a number, so it can go up. Like when people become senile, like they grow old, their IQ goes down. So yeah, so I think that kind of like IQs can be built and all that, but I don't know, I cannot explain to you. I know my goal is not what you think that is, but I know what my goals are and all that. Yeah, I'm not taking prompt for literal, but I'm conveying that no number is number one in CS still. Now even the top one's like, I know that. I know that. Bro, just to become the god, to become the god of programming and all that, you have to know like everything there is about computers, all these, everything. But that's not possible for a human brain. You can be either top AI, web, cryptographics, take 2 tickets. Yeah, whatever. let's not think about how much time it's gonna take to become whatever top number one or one number. We are trying to become good here. That's our goal. Every day better than the yesterday self. That's the goal, okay? So yeah. There can be many interpretations of my words, you know. Yeah, but to my brain, today was a hectic one for me. What happened? What you did? As a case study, an experiment, we are going to create an array of random integers between 0 and double line inclusive. Then we create a loop where we sum up all its integer under 15. Integer I, okay. तुम घुसेड़े जा रहे हो. What's a RAND? Oh, I think that random integer between 100. Oh, that gives a random integer, I guess. Oh. What you did? Then we create a loop where we sum up all its elements under 50. Volatile. The language is different, man. Wake up at 9:45, started solving DSAs from 10 to 1, work around for half an hour, fix a bug on our portfolio, was learning distributed systems, took like 3-4 hours more than Anki took 34 hours, 1.5 reading, record, novel reading, record for me. She, yeah, doing some shit. That's started, okay. But नया वाया नहीं क्या 10 बजे बैठ गया 10 12 1 3 hours 1 4 4 4 4.5 4.5 8.5 well, 9 hours you did 9 10 10.5 hours ना शाम को नहाया आज मैंने तो I woke up and then I like I went to the kitchen and there was a bhindi ki sabji, you know what you call that, okra, yeah, okra ki sabji, bhindi ki sabji. To I couldn't resist, man. I had to eat and then I started streaming, reading, and for 40 minutes of reading I did, and I became so sleepy because because of the glucose started mixing into my bloodstream or whatever, I get sleepy after I eat, so yeah. So for that reason, I had to take like 50 minutes of break on the stream. Yeah, but now because of that 50-minute break, I can go up to 8 to 10 hours now. So that is okay. I like this casual better, like Uto Sida Kam Baki. That is so true. Like, yeah. बाकी टाइम मैं woke up and do random shit, Insta all बाहर सारा ले जाता है अब आराम से free हो Rick and Morty finally देखूंगा anime. That is so true. I had the same. Yeah, you know, today's your schedule. Today's your all things, like how you did the things. I had that routine for many months when I used to do streams. Like सर्दियों में तो मेरा यही routine होता है. I wake up and I do my brush, wash my face, and come and start doing my stuff. That is the best way. And like other days, normally in the summers, I wake up and then, yeah, it's so like you start scrolling on Insta and like 1 hour is gone. Then I'm like I have 3-4 SNS accounts, social media, so I check everything, and this and that and that, and like I spend around three something hours, some days 4, some days 5 in the bed even after waking up. And that is so shit. Yeah. Then I could only do, after those 5 hours, I could only do like actual productive work for only 2 or 3 hours. So the whole day is wasted. But right after waking up, started doing your, work that's the best thing. Best thing in the world. Yeah, for me, I spend my morning doing some random shit like random YTPC. बहुत टाइम ले जाता है, फिर नींद आती है शाम को. बट मॉर्निंग में इसी जो एनर्जी थी पता नहीं लगा DSA के 3 घंटे का. Yeah, morning is very wow. After waking, when you do your stuff, like your brain is at the highest productive levels. It's the peak hours of your brain after waking up. Like give it a 15 to 20 minutes of settling down, and then you can start your work. We see breakfast भी 1 बजे किया था. That is, yeah, that is the thing. Like सुबह उठते अगर खाना खा लिया ना, you cannot do shit. Like try that tomorrow, okay? Wake up, eat breakfast or whatever, eat something, and then if you'll start working or studying, you will not be able to continue that for more than 5 hours or something, not 2, 4, 5 hours. So yeah, I do the same thing, but today I did bra. कीड़े आ रहे हैं भाई, कीड़े आने लग गया भाई. Not yesterday. I mean, in winters I only take 1 meal a day, just cause like I feel sleepy because of all that eating. For the last week, I've been trying to get to that routine of eating only one time. Yeah, bah. And only at night. मुझे पता है previously what I used to do is whenever I sit for study, my mom bring me breakfast, तो मैं सोचता था कि 10 मिनट की बात है, खा लेता हूँ, उसके बाद पढ़ लेता. खाना खाने के लिए खोला बीफी गए, हमारे ब्रेकफास्ट पड़ा 4 घंटे का. Bro, you cannot, like after eating, you cannot just start working immediately. No, that the carbs, like Indian breakfast, Indian food doesn't have that protein and all that shit. It only has carbs, which give you like fatigue. I mean, yeah, it makes you very sleepy, very tired. It sucks all your energy from inside you. So yeah, when I eat, I usually take around at least like 30 to 1 hour, 30 minutes to 1 hour of break, just so my body can adjust. And yeah. That gives a random number, right? Between 1 and 100. 0 and 1 and 0 and 100, right? Yeah. Hi man, I will not waste any more of your time. You read your HPC docs cause you wanna be number one programmer. I'ma watch my Rick and Morty final, can't wait. Yeah, bye bye. Rick and Morty. Rick and Morty guy. Just. क्या है बे? सीधा सीधा नहीं है क्या कोई? इतना नहीं करना चाहता ना मैं. मैक्स मिन यही कॉपी कर लेते अपन को. यही तो करना है हमने को. हाय बाय बाय. गर्मी हो रही है बहुत भैंस की. I don't know. Okay. Maximum 100 0 0, that is fine. I don't need to though. Between 0 and 99 inclusive. So that gives returns a whole number from 1 to 10. I don't need to write that. Do I need to? Can't I just do that? Let's see. Inclusive. Why not 100 only? I don't want 100 to be there. Okay, then we create a loop where we sum up. As a case study, we are going to create an array of random integers between 0 and 9. I don't need to know. Then we create a loop where we sum up all its elements under 50. What's a volatile? Temporary? परिवर्तनशील. Whatever. I'll just get that. Let S. Okay. For let I is equal to 0 and I tell that n I n plus plus if a if I is equal to 50, then P S plus equal what is that? And is I don't have an 99. Oh shit, it's not gonna. 9, yeah, that's fine. Bara 15 55 63. Then we create a loop where we sum up all its elements under 50.ちょっと待って. Here. Not a number, fuck. Huh? 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 Why is it not a number? 0. Yeah. I don't get it, man. I don't need to do this. I just need to read it, man. Okay. Imagine ridiculously smart enough to that old statement costs almost zero extra cycles. Why did I sell the man? Without the regular condition of this invitation of the signal, the page will synthesize the difference between relying on hardware branch predictive and writing deterministic, branchless software. What is in C++, I think? It was compiled directly to machine code using client or Java operators with a JVM. It does not spit out by meta assembly like that useless like that unless you are doing to GIT compile. You want to talk to a system instance, good job there. Tell it right now. Copy it once, but language the copy it once. Architecture options about the memory. Yes, the instruction language. It's just print and pass. You targeting a random what the you write. So script will not think replace the assembly or level 2. What do you think? Maybe you can choose that one. What do you favorite does to use JavaScript and it was fun? JavaScript does not run on magic. The engine takes your JS loops, compiles them down. JavaScript does not run on magic. The engine takes your JS loops, compiles them down. It's turbofan optimizing compiler and generates out same raw sampling instructions here. Starting at in that screenshot. If you don't understand what the CPU is doing in that C++, it's saying you do not understand what JavaScript actually do. Should I run the code expert? No, I'm not going to force you to install C++ a package configure plan and set a path there. If I need to is write this second, this is a distraction from the immediate objective. You will read the experiment, you will choose the logic. You will understand actually why that specific statement causes a branch misprediction. Statement causes a branch misprediction and why the execution time jumps to 14 CPU cycles instead of 4. You will visualize the pipeline being finished. The unpaid data. Do not attempt to use this version to do assignment. I'm not dodging it, boy. I give you 3 specific concepts to synthesize. Shut up! Come on! Goes they through? Goes they? Goes they sort of thing, nani? 何のこと？ちょっと待ってください。合成。合格。Composition, synthesize, combining. Potassium is an element necessary for protein synthesis. Go say saying. Okay, ma, I don't need to do this, ma, but I can just, I just need to understand what's going on over here instead of actually doing it, okay? We are still a beginner, okay? We are here to extract information out of this article, not actually doing it. Ma. Okay, when a CPU encounters a conditional jump or any other type of branching, okay, it does not just sit idle until its condition is computed. Instead, it starts speculating, executing the branch speculatively, and instead it starts speculatively executing the branch that seems more likely to be taken immediately. During execution, the CPU computes statics. Again, during execution, the CPU computes statics about branches taken on each instruction, and after some time, they start to predict them by recognizing common patterns. For this reason, the true cost of a branch largely depends on how well it can be predicted by the CPU. If it is a pure 50-50 coin toss, you have to suffer a control hazard and discard the entire pipeline, taking another 15 to 20 cycles to build up again. And if the branch is always or never taken, okay? And if the branch is always or never taken, if the branch is always or never taken, you pay almost nothing except checking the condition, okay? And case study, we are going to create an array of random integers 0 to 99 inclusively. Yeah. Then we create a loop where we sum up all its elements under 50. Right, I know. Okay, volatile int as 50. Okay, we create a loop where we sum up all its elements under 50. All its elements under 50. Okay, under 50. So how many? So many, like all the elements which are under 50. Okay, you see that? So we set n is equal to 10 to the power 6 and run this loop many times over so that the cold cache effect doesn't mess up our results. What's our cold cache cache? We mark our accumulator variable as volatile so that the compiler doesn't vectorize the loop. Vectorize the loop? How do you vectorize the loop? What do you mean by vectorize the loop? Shit, this shit is cool. Changing a sequential code loop into an operation that processes multiple data items at the same time. Vectorizing a loop means swap manual loops for a pre-compiled array tools like CumSum. Single instruction, multiple data. This uses a loop. Vectorizing a loop means changing a sequential code loop into an operation that processes multiple data items at the same time. Changing a sequential code loop into an operation. Sequential code loop into an operation that processes multiple data items at the same time. Multiple data items at the same. Okay, whatever. We set n to 10 to the power 6 and run this loop many times over so that the cold cache effect does not mess up. So that the cold cache effect does not mess up our results. We mark our accumulator variable as volatile. We mark our accumulator variable as volatile many times over so that the cold cache effect does not mess up our results. Should I just read about this as well? Oh my fuck lord, I ain't doing that, man. The dog is pretty cool. Cache lines and all that. Gee, this looks so cool. Section key studies, binary search, static keys, search keys. I'm gonna read it sometime. I'm not worthy enough to read this. Now, oh, what's this? Oh, that's a match programming languages. Compile languages now. It's time for C. Blast. Take away. Take my away. Computer architecture. Complex models. Damn. Okay. Okay. Now we mark our accumulator variable as volatile so that the compiler doesn't vectorize the loop, interleave its iterations, or cheat in any other way. On Clang, this produces assembly that looks like this. Blah, 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 blah. Oh, I get it all. Our goal is to simulate. Our goal is to simulate a completely unpredictable branch, and we successfully achieve it. The code takes a 14 CPU. What 14 CPU cycles per element? Where is it written? I don't get it, man. What is this? The code takes 14 CPU cycles per element for a very rough estimate of what it is supposed to be. For a very rough estimate of what it is supposed to be, we can assume that the branches alternate between this BS and and the pipeline is mispredicted every other iteration. Mispredicted every other iteration? Then every 2 iterations. Huh? Our goal is to simulate a completely unpredictable branch, and we successfully achieve it. The code takes 14 CPU cycles per element for a very rough estimate of what it is supposed to be. Yeah, what? Our goal is to estimate What the fuck? Why am I taking this much time? Our goal is to estimate, is to simulate. Our goal is to simulate a completely unpredictable branch, and we successfully achieve it. The code takes 14 CPU cycles per element for a very rough estimate of what it is supposed to be. We can assume that the branches alternate between this, and the pipeline is mispredicted every other iteration, then every 2 iterations. We can assume that the branches alternate between the pipeline is mispredicted every other iteration, then every 2 iterations. We discard the pipeline, which is 19 cycles deep on Zen 2. Discard the pipe, which is 19 cycles deep on Zen 2. It has 19 stages, each taking 1 cycle. We need a memory fetch. And a comparison, which costs 5 cycles. We can check the conditions of even and odd iterations concurrently. So let's assume we only pay it once per hour. In the case of we need another 4 cycles to add to a volatile memory stored. We can replace the hard-coded 50 with a tweakable parameter p. That effectively sets the probability of the branch. Now, if we benchmark it for different values of p, we get an interesting looking graph. Interesting. It is interesting. Okay. Boom, boom, boom. I. P. Branch probability. Its peak is 55% as expected. Branch miss prediction is the most expensive thing here. The graph is asymmetrical. It takes just 1 cycle to only check conditions that are never satisfied. Its peak is at 55% is expected. 55% expecting. Branch miss prediction is the most expensive thing here. The graph is asymmetrical. It takes just 1 cycle to only check conditions that are never satisfied. P is 0, and 7 cycles for the sum if the branch is always 7 cycles. One cycle if that never satisfies, and 7 cycles. 1, 2, 3, 4, 5, 6, 7 cycles. If the branch is always taken p100. This graph is not an unimodel. There is another local minimum at around 85-90% we spend, or about 10-15% faster than when we always take the branch, accounting for the fact that we need to perform fewer additions. Branch misprediction stops affecting the performance. Oh god fucking damn it, this is so fucking No, that it costs almost nothing to check for a condition that never or almost never occurs. This is why programmers use runtime exceptions and base case checks so confusing if they are indeed right. They don't really cost anything. In our example, everything that was indeed for efficient branch prediction is a hardware static counter. If we historically took branch more often than branch B, then it makes sense speculatively execute branch A. But branch predictors on CPU are considered more advanced than that and can detect much more complicated patterns. Let's fix P back to 50 and let's start the array first before Summation. We are currently processing the same number. Bro. Okay, I don't get it, man. Branching overhead can mean two different things depending on context. The delay in computer processes caused by conditional jump instructions or extra work and slow down in the software teams caused by the managing too many version control branches. In the computer architecture, a branch instruction tells a processor to jump to a different set of instructions based on a condition like and if else. Pipeline stalls. CPU processes instructions is a steady line. Steady line pipeline. When a conditional branch happens, the CPU must guess which path the code will take. If the CPU guesses wrong, it must throw all the work away in advance and restart them down the correct path. That wastes time and life cycles. Modern chips use advanced branches predicted to guess correctly most of the time, reducing the time work permanently to near zero for predictable code. Suck my dick. Sorry. Suck, you can such it. Hardware technique used by CPUs to guess output of conditional operations. Before the CPU evaluates them, allowing it to speculatively fetch, execute instructions to keep the process pipeline full. It is essentially for modern high-performance computing, minimize the penalties of processor. Modern processors use pipelines, meaning they break instruction executing into multiple steps. I should know. Oh shit! What the shit kind of branching overhead? At the physical hardware level, what is happening to the instruction pipeline in the CPU encounters and conditions here? I did not expect. CPU's branch predictor is so intelligent and you can Osha! Oh voyage! Bon voyage! Look at the data we just. The CPU started. You claim that putting I if inside the loop is bad because CPU makes a speculation which could be wrong, and that adds up some cycles. Look at the data you just read. The CPU is statical pattern recognition machine. If your loop runs 10,000 times, the condition is not going to be true 999 times in a row and false exactly once at the very end. Do you think a modern CPU predictor is going to mispredict that? It is mathematically perfect sequence. The hardware will log onto that pattern instantly. It will predict true perfectly for 99 iterations. It will only mispredict exactly once on the absolute final iteration when the loop terminates. The branch prediction hardware handles this specific if statement flawlessly. So I ask you again, if the hardware is smart enough to predict the branch and avoid the cycle permanently, why did I still demand that you remove it? You miss the fundamental philosophy of the system. अरे यार भाई जब बता देना तू तो तू बता दे मुझे क्या बताए. And why did I still demand that you still remove it and use O1 mutation? Because you miss the fundamental philosophy of the. Don't ask me again, man. I don't get it, man. You are thinking only about the penalty of a wrong guess. You forgot about the physical weight of a correct guess. Even if the CPU predicts the branch perfectly, the if statement still exists in the memory. It still has to be fetched. It still has to be decoded. The CPU still has to physically route the variable through its arithmetic logic unit to evaluate if I is not equal to n. If you put that conditional inside the loop, you are adding a CPM compare instruction and GMP jump instructor to the inner body of your loop. If you put that conditional inside the loop, you can have my ass. Okay. If you put that conditional inside the loop, you are adding a CFP compare instruction and JMP jump gone. Jump the company jump CMP bada boom. GMP bada boom. Okay. If you put the conditional inside the loop, you are adding. I am adding, okay. You are adding a CMP compare instruction and a JMP instruction to the inner body. To the inner body of your loop. If n is 10,000, you are forcing the CPU to fetch, decode, and execute 20,000 completely useless machine code instructions just to prevent a single line break. If n is 10,000, you are forcing the CPU to fetch, decode, and execute 20,000 completely useless machine code instructions just to prevent a single line delete. You are polluting the processor's instruction cache with garbage. An architect does not write redundant logic just because the hardware is fast enough to hide their sloppiness. The for loop already knows when it is going to end. The condition I is already handling the termination state. The condition I is already handling the termination state. Putting a second check inside the loop body is structural redundancy. By removing the if statement entirely and executing a single one hop at the end, you strip the inner loop down to the purest physical form. Yet the processor, you let the processor run at maximum velocity and you handle the cleanup only when the heavy lifting is finished. Now, you understand the physical hardware, you understand memory allocation, you understand string mutation and instruction reading. There is no more theory to discuss on this specific pattern how to do that. You will now write the final perfectly version of a software. It will be unified variable by April and exactly I will have zero internal relations with the line there. I will be sanitized. ओ तेरी माँ का तेरी बैंड दा तेरी बैंड दी तेरी भाड़ दी ओ तेरे माँ की ओ भाई ओ भाई ओ भाई ओ क्या है भैया ये क्या है यार if the hardware is smart enough to predict I need a break, fucking break. स्वामी रामदेव कहाँ मारे अम्मा मिनमा सारी उम्र में मैं जोकर बन जाऊंगा मैं तो जोकर का जोकर बन जाऊंगा 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 What? Oh, wow. Bravo. How are you? अच्छा बेटा ऐसी बात है कि हाँ अच्छे 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 बेटा Shut up. Chica color. 日本 QR に QR コードインスタントラーメン mucho. おやおや。美味しいです。JavaScript arrays are dynamic under the hood. V8 allocates a chunk of contiguous memory. V8 allocates a contiguous memory for your array. When you push past its capacity, V8 has to allocate a new larger chunk of memory. Copy the old element over and add your new characters and garbage collect the old memory block. Here, triggering the relocation process repeatedly. Triggering the relocation process repeatedly by feeding the array one byte at a time. Furthermore, you are executing a JavaScript for loop to do something the underlying C++ engine can do natively in a fraction of cycles. Once you have written it. Yeah, and that's the reference of the website change. Yeah, we are making its contents. Now, we are sending the web page faster and the content is possible. Transfer to down this one specific purpose. Bottom loop. Chama Middle. Chama Middle. Chama Middle.